everyone, it's Justin again. You've made it pretty far in this unit, and this is your final lesson before the wrap-up. In this lesson, I want us to take a step back and start to think about some real-life scenarios where we can apply some of the things you've learned. Now, of course, there are fancy careers out there that use the concepts from this unit all the time, like careers involving community development projects, public health, finance and investments, and many others. The list really could go on and on. But at this point in your life, having a career like this may seem to be ages away. So how can you apply some of what you've learned now to the life you're currently living? That's what this lesson's about. And in order for us to get started, you're going to need to do a little work on your own first. There's an activity in your PDF called Translating Using English. If you haven't done this activity already, you definitely need to before continuing with this video. So pause the video now and work through it. I'll meet you back here in a moment to talk about it. Here are the lists you were provided with in the activity. They have some phrases that the inequality signs translate into. Remember as we go through this lesson that these lists don't contain every single way that these inequalities can be said. If you think of or encounter any additional ways to say these, be sure to add them to the lists on your paper. Anyways, let's talk about this example first. These different ways of saying that the price of the toy is more than $15 were given to you to read through. They all mean the same thing, even if some of them aren't how you naturally talk. I know I wouldn't normally say that the price of something surpasses any amount, but if I heard someone else say it, I would know that they're still saying that the price is more expensive than a certain amount, just like all the rest of these. Anyways, part of this lesson is about translating to English. But the other thing I want you to be able to do is think about your answer logically and see if there are any adjustments or restrictions that you need to make based on the scenario. Remember that this inequality means every number greater than 15 is a solution. That includes numbers such as 25.4378 and 700.46. But does every single number greater than 15 really makes sense in this scenario? What would some exclusions be? For example, in a scenario that uses money, we need to keep in mind that there isn't a currency smaller than a penny. So a price like 16.09 would be reasonable to pay. This would be $16.09. This 9 in the hundredths place represents pennies, but what if there were more numbers after this 9, like these? We don't have money that goes past the hundredths place, so we can't pay amounts like that. Let's start a list of restrictions so we can tell people that, logically, numbers past the hundredths place won't work for this scenario. Is there anything else you can think of that's greater than 15 but just wouldn't make sense in this scenario? What about numbers like these? This is where it gets tricky. How much money people are willing to spend on a toy is different for everyone, but we know there has to be some limit to how much a toy can cost because there's only so many dollars in the world. Since we don't know exactly what the limit is, we can just say here that the amount can't go to infinity. And that covers all the restrictions for this scenario. We already knew the price had to be more than $15, but there were a few other things to keep in mind that just wouldn't make sense here. Let's keep going through that activity and check out this scenario about temperature. This says that the temperature is a minimum of 10 degrees Celsius. And here are some possible sentences you could have used to say the same thing. Or maybe you used some of the other phrases from your greater than or equal to list to make your sentences. Go ahead and read through these and verify that they make sense with the list you were given, even if they don't match what's on your paper. Next, let's talk about the reasonableness and logical restrictions that this scenario may need. We know that there are a lot of numbers that are solutions to this inequality. 10 and any number larger than 10 makes this statement true. But since we're talking about temperature, is there anything that should be excluded? Technically, with temperature, we can have decimal amounts. It can be 11.5 degrees, and it technically could be 13.854 degrees too. If this were a more specific scenario, there could be more restrictions. But since this is just about what numbers temperature can be in general, we don't have to worry about that. But is there anything else you can think of that would be a logical restriction on this scenario? We wouldn't want to go all the way to infinity. I mean, it can only get so hot. Even if we're talking about the temperature of a hot plasma ball or something, it could still only get so hot. So let's say that's our logical restriction here. We know that the temperature can't go to infinity. What about the next scenario? This says that the binder has a maximum capacity of 200 pages. First, go ahead and check these answers with yours. Remember, your sentences may not match mine, but if the phrases you used came from the list you were given, you can be confident that they're correct. Pause the video and do this now. Next, let's talk about the logical restrictions on this. What are some numbers that would be true in this inequality, but really should be excluded? Technically, this number is true in the inequality, but doesn't make sense of the scenario. Why doesn't it? Yeah, it's negative, and we can't put a negative number of pages into a binder. And it's also a decimal. Were you just thinking, well, I could cut off part of a page of paper and then put what's left in the binder, and then you have a part of a page? Let's be real. When you're using a binder, you wouldn't carefully measure decimal parts of pages. And since these scenarios exist in the real world, we want to think about what is reasonable, not just what is technically possible. But anyways, I think we figured out our logical restrictions. We wouldn't want negative numbers or decimals. Here's the last one from your activity. Take a moment to go through these answers and compare them to what you wrote, being sure to relate back to the list of phrases you were given. Pause the video now so you have time to do this. What do you think some exclusions are for this scenario? Or do you think any number less than 5 makes sense? Well, a child's age can't be negative. And honestly, a young baby probably isn't going to be able to play either. So there definitely needs to be a reasonable lower boundary here somewhere. Maybe something like this. And I think that's it. Their ages can be 4.5 or other decimals, so I wouldn't say that's a restriction. And there we have it. You've now learned to translate mathematical inequalities to the English language, and to reason through the logical restrictions that a scenario can place on an inequality. There are some great bonus options in your PDF for this lesson, so I really encourage you to try some or all of those either before or after you complete the practice game. That's it from me. Good luck with your practice, and I'll see you next time.